Okay, the first one, we need to answer true or false. This is from last semester. Remember, I said that it doesn't ever go away. From chart 5, the object's displacement can be determined by finding the area under the line. Would this be true or false? Okay. Now can y'all see? Okay. Can you, true or false, determine the displacement under the area of a line here? False. Why can you not do that? Because this is a distance versus time graph. That you would have to have a displacement versus time, a velocity versus time graph to find the displacement under a graph. Okay? So that one was false. Number 2, the object is not moving from 10 to 11 seconds. Okay, is this true or false? True, because the distance is not changing. Now, what if this had been a velocity time graph? What would you say instead? It's still moving, but it's going a what? Constant speed or velocity. Okay, number 3, a fly riding on the spinning blade of a fan at a constant speed is accelerating. Okay, remember, there's centripetal acceleration. Don't forget that. Also, remember, the velocity is not going to stay the same because what changes? The direction. Okay, so if your velocity is changing, you call that what? Begins with an A. Acceleration. Okay, so number 3 then would have been true. Okay, number 4, mass is the measure of an inertia of an object. True or false? True. Remember we said if you see mass, what word are you going to link it with? Inertia. All right. Number 5, the net force on an object is the resultant of the force vectors. Okay, well, let's think about what we do here whenever we're doing one of these problems.
Dr. Howard?
Yes, ma'am.
Can I see Natalie for a moment about testing?
Okay.
Okay, thanks. We talked this morning, but I need to talk to her 1 minute.
Okay.
Thanks.
So what this is asking us, shh. All right, listen, please. The resultant, the net force is the resultant of the force vector. So let's ask us this question. Let's say that we've got one vector with a force of thrust this direction, another vector, what might be opposing force of thrust? Force of friction. Now, the resultant vector is going to show us the what? Not only direction, but the what? The magnitude of our net force. So let's say that this equals 10 newtons and this equals 2 newtons. What would my resultant look like? It would be 8 newtons in which direction? Okay, so is that statement true? Yep, the net force on an object is the resultant of the force vectors. Now, could we also apply this to a triangle situation? All right, where we had something hanging from a ledge, maybe. Remember, this is a wall right here, and then we have a little support beam. We have a flower pot on it, and if we want to find the force that is here, we'd have to divide it up into how many components? 2. This is two-dimensional force. How would we find the x component or horizontal component? What would we use? Not for x. Cosine for x and sine for y. All right. Number 6. Centripetal acceleration is center-seeking acceleration. True or false? True. Now, number 7. A ball that is dropped will hit the ground at the same time as a ball that is thrown horizontally with initial velocity of 2 meters per second. True or false? True. Because remember, y'all, we saw that little experiment. It doesn't matter whether it's thrown or whether it's dropped. What acceleration is bringing it down? Gravity, 9.8 meters per second squared. Make sure they're awake, please. Okay? All right. This one right here, I think we've actually had this one before, number 8. But remember I said, anytime you see the words equal and opposite, or you see mathematically equal and opposite, or you see arrows that are pointing equal and opposite, what law is that? Newton's third law. Okay, number 9. Which statement best describes how Newton's third law is applied to a rocket being launched into space? Now before I get into this, if you see the words third law, what does your mind automatically think?
Equal and opposite.
Equal and opposite. Alright, and so which one of those contain those words? B. The exhaust gas is pushed against the ground, and the ground exerts an equal and opposite force, pushing the rocket off the ground. Did we do something like this? Yeah, we did. We did it with what? What test did we do? Newton's third law. Balloon. We did our little balloon races, didn't we? Alright. Now I'm going to go ahead and cover number 13 since it's up. We already talked about this one, right? In class, that was word for word. I don't even think I changed anything. So what was the answer to number 13?
B. Oh, it's D. What is it? I can't see.
Oh, that's the
It's B. No, it's not.
No, it's not.
It's D.
Okay. Okay.
It's D.
Okay. Stop for just for a second, okay? Can somebody tell me why number 13 what are some key words that tell us that number 13 is D? Mass stayed the same. Okay, keywords, mass stayed the same. So we could have eliminated, tell us why we would eliminate choices A, B, and C.
Because the mass is changed.
Okay, so that one was a kind of a gimme, right? Alright, especially since we had it before. Alright, Jacinda is pushing a shopping cart. .45-degree angle. Nope, this is not a difficult problem. How do you get the horizontal component? Okay. How do you get the vertical component?
How do you get the vertical
Okay, so we've got a shopping cart here. And she's got a 45-degree angle. Can y'all see the angle? Alright, now first of all, let me ask you, out of common sense, 45 degrees is what? It's half. It's in the middle. Okay, so before you do anything, just tell me common sense what you think the answer might be. Just out of common sense.
Can't see the answer choices.
It's this one right here, right? Okay. 45 degrees, and she's pushing with a force of 40 newtons, and we want to know the horizontal component. Okay? So what we have here is a triangle. This vector, we got 45 degrees, and this vector is 40 newtons. So if we want to find the horizontal component, we're going to take the sine of 45. Horizontal, we're going to take cosine. X, horizontal. Yeah. Okay, to find vertical, we'd take what? Sine. Okay, now can anybody look at your little chart and tell me what is the relationship at 45 degrees of your sine and your cosine? It's what? What do you expect it to be when it's half and half? Yeah, you expect it to be the same number. What is that number?
I don't understand.
Okay, an angle that is 90 degrees, right? Half of it is 45. Okay, so you would expect your mass to be distributed equally, since you got a 45-degree angle among the components horizontal and vertical. Now, when we're talking about sine and cosine, what would you expect your number to be as far as sine and cosine on a 45-degree angle? Equal. Open. Get your sheet out and tell me what is the 0.707. Okay, so the cosine of 45 degrees and then our sine of 45 degrees was also 0.707, right? Whoops. Okay, is everybody with me? Anybody not with me? Okay, so we're going to take the force along the x-axis is going to be the cos of theta times our resultant force, right? I'm just going to put R there for our resultant force. So it's going to be 0.707 times 40 newtons. What's 7 times 4? Okay, so let's go back to our answer choices here. Number 10, what's the correct answer? Did you need a calculator for that? Nope, you had your sheet there that had the angles on it. Any questions on that? Do you have a question? Okay, if you're trying to find horizontal component, you multiply by the cosine. Uh-huh. Okay, if you had, for example, like 40 newtons times 0.658, is that what you're asking? Like that? Okay, well, you would just multiply the whole thing. The only thing is, remember, when you're doing multiple choice, you can pick out the right number a lot of times without doing the whole thing. Because, see, over here, we had 0.707. So we know that 7 times 40, or 7 times 4 is 28, right? Okay, so I can go ahead and I can work out the whole problem. Okay, 0.707 times 40, 0, 8, 2, okay. 8, 2, 4 times 7, 28. 30, 1, 2, 3. Okay, now did I have an answer choice that was what was my closest answer choice to that? 28. Does that make sense? Okay, now I can go ahead and there's nothing wrong with actually working the problem out. And of course, if you're doing an essay question or a problem where you're showing me how to solve the problem, yeah, work it out for me so I can see where you've rounded and what you've done. But when you're doing a multiple choice question, again, one thing that separates the men from the boys on standardized tests is how quickly you can do the questions. And this is a test-taking technique. Make sense? Okay. Okay, number 11. What is the average velocity of an object moving 10 meters in 50 minutes? Again, this is absolutely nothing but a super simple physical science problem. If you can't do this, then you need to really be rethinking your value, I guess. Does that make sense? Nope. If you can't do a simple physical science problem and you're in physics, then you're not doing a good job. Velocity, very simply, is distance over time. What was my distance? $50 seconds? Minutes. Okay. What's my... Huh? Meters? Okay, was that what I said? Okay. Now, what are my units that I end up with? Meters per minute. Is that a correct unit for velocity? Yes, it is. Okay, what's 1/5? Okay, 0.2. Okay, now how many of you did what you did the other day and said 50 divided by 10? Did some of y'all do that? Okay, the other day I gave you this problem, and remember I kind of fussed at everybody because I said, being a physics student, you shouldn't make that mistake. You shouldn't say 50 divided by 10 equals 5. But yet I got a whole bunch of answers that said 5. Yeah, like probably half of the class or more would have said the answer was 5. Does anybody not understand what's going on here? Did you need a calculator for that? No, you did not. Okay. 4 pairs of objects have the masses that are shown below. Now remember, what is the big important thing with the Universal Law of Gravitation? It's not necessarily remembering what the great big G stands for. But what's the big important thing you learned about universal gravitation? Okay, then somebody tell me, look in chapter, I think it's 7, to tell me what is the universal law of gravitation. Remember, it's one of those overarching concepts that you're going to see in electricity. You're going to see it in kinematics. Okay? The equation for the law of universal gravitation. Yep. Yep. Okay, so again, did you have to do math on this? No, you did not. Did you have to know what the G, or what this K stood for? Actually, I think in this one it's a capital G, but in regular math, any constant is represented by a K. Did you have to know what that number was? No. All this question asks you, you've got which one is going to have the most gravitational pull. Are we going to end up with a big number on top or a little number on top to get the most gravitational pull? You'd want a big number on top, wouldn't you? Okay, so which pair of these has the biggest numbers that would go on top? Very good. 12 is C. Okay, did you have to use a calculator on that? Okay, you know that you're going to get a question that's going to ask about the radius. As something gets farther apart, your radius becomes what? Larger. So what happens to the gravity between those two objects? It gets what? Weaker. Because this number on the bottom gets big. Y'all see that? Okay, so remember, they like to do this. This is a separate the men from the boys problem on any kind of state standardized test or ACT or SAT or whatever. They want to say things like, and then I'm sure I'm going to say some things like this, if you double the distance, okay, if you double your distance, what effect does that have on your gravity? Or excuse me, 2r squared. How does our gravity change? Does it change by 2? Okay, look at the equation. Let's pretend like I gave you a problem, and I didn't give you a bunch of numbers, but I said, what happens when you double the distance? Okay, when you double the distance, you would say 2r squared. So what's 2 squared? 4r squared. So that means that when you double the distance, the gravity has decreased by what? Decreased by 4. What happens if you triple the distance? Decreased by not 3, not 6. What's 3 squared? 9. Okay, what happens if you half your distance? What does it do? No, if you half your distance, it's not going to decrease, but increase by no, 4, because remember this is squared. Okay, so these are the kind of questions that they ask you to make sure you understand the actual math, the meaning of the math. Now remember, anybody who's in physical science, they can plug in numbers, they can take their little calculator, and they can just plug in some numbers. But it takes a person who really understands something to do more important things and make more money, okay? So they want to know, whenever they're asking you these kind of questions, do you really understand the math behind it? All right, number 14, another super simple physical science question. You did, huh? let's see. Our velocity change is 25 meters per second divided by 5, and what did you get?
I put D.
Oh my gosh. How many of you put D? Okay. Now let me tell you my little trick here. Y'all listen very carefully. Okay, when you had this question, I'll wait for y'all. Yeah, I'll wait. Now, when I gave y'all this question for a little quiz, what was your answer? It was 12.5. But what's something that I do a lot of times whenever I'm giving tests or even different versions of a test? Change my numbers. So my acceleration is my change in velocity over my time. And in this case, it was 25 meters per second divided by 5 seconds.
5 squared.
Okay. So, what I look at whenever I see, I'll wait. So whenever I see somebody that just chose 12.5, what do I think that y'all did?
Oh, don't take that from me, because I thought it was a different problem. You know what I'm saying? I got that.
All right. Yeah, make sure you always work it out. Okay. Now, we've had number 15 how many tests now?
A lot. 13.
Okay. We've had this a million times. We had this one, number 19. Now, the only thing I'll wait because I've got all the degrees. I can't get any higher degrees.